Bismillahirrahmanirrahim. Welcome to the channel. My name is Asim Amjad, and in this video lecture we start discussing the topic that is statistically indeterminate beams, and for that we actually solve this problem. So we have to solve this problem for finding the force and moment reaction that is acting on the beam that is shown below. So we can solve this problem by using two methods that we covered in our previous video lecture number 14. So first we solve this problem using the superposition method, and then we solve this problem using singularity functions method. The issue by using the superposition method is that sometimes we didn't found the values from the table, and that's why it's a little bit difficult for us to solve a problem. Then we can use the singularity functions technique. So that's why we use the same problem to solve it for the singularity functions. So let's start by solving this problem using the superposition technique first. So first of all, we have to find the reaction forces, that is AY, that is acting upon here due to this fixed position at A, and the reaction force By is acting here at point B due to this pin spot, and the moment is acting anti-clockwise, that is Mr at A. So according to equilibrium condition, first find the forces in the y direction, and we take the forces upward direction as positive. So the equation is Ay minus 73 times the length of this distributed force, that is 1.8 plus 0.6, that is 2.4. The point load which is acting over here, that is 45, as moving downward, so minus 45 plus By. And then we have the equation number 1, that is Ay plus By is equal to 220.2. And now for solving the moment at point A, we taken as the anti-clockwise moment positive, and the summation of all the moment at point A would be 0 according to the equilibrium condition. Then the moment that is acting at the point shown here, that is A, Mra minus 73, the distributed load that is acting over there. So 73, so the magnitude of the load, that is 73 times 2.4 times the distance, that is 2.4 divided by 2, as this load is distributed over the whole length of the beam. As this is the UDL load, so the resultant load is acting at the center. So the distance from center to this point would be 2.5 over 2 minus 45, the point load that is acting over here, times the distance, that is 1.8, plus By that is acting upward, and the distance from this to this point is 2.4 equal to 0. And then the equation 2 will become Mr at point A plus 2.4 By is equal to 291.24. So now we have two equations and three unknowns, so we can't solve that. For that case, we first use the superposition technique. So हमने previous video lectures के अंदर इस टेक्निक के बारे में डिटेल से पढ़ा है. अगर आपने वो वीडियो पहले नहीं देखी तो आप पहले वो वीडियो देख लें. तो हम इस बीम को अब रिजोल्व करेंगे इस तरह से कि सबसे पहले हम डिस्ट्रीब्यूटेड लोड कंसीडर करेंगे हमारे इस कैंटिलीवर बीम के ऊपर, और ड्यूरिंग दैट डिस्ट्रीब्यूटेड लोड जो डिफ्लेक्शन है वो y1 हो रही, जो कि यहाँ पे अट रही. फिलहाल हम इस पिन स्पॉट को कंसीडर नहीं कर रहे. और फ्रॉम द beam deflection table, we know that the maximum deflection is WL14 over 8EI. You can simply check it out. Then we are considering this point load, that is 45 kilonewton, or that is acting at this point. So we know that the maximum deflection, as in the case of cantilever beam, is acting over there. and we actually solved this problem in previous video lecture, so you can also check it out for how we find the y3. So as the point load is 18 out there, so this deflection is y2, and the maximum deflection is definitely in the case of cantilever beam is occur at the end of the cantilever beam, that is y3. So the value of this distributed deflection load is PL2 3 over 3 EI, and the deflection of this case at the length of L2 is PL2 per cube over 3 EI, and the slope at this end is PL2 square over 2 EI. And now we are considering this support, the pin support, that's actually apply the force to upward direction, and the deflection would not be moving to the downward, it would be moving to the upward. बिकॉज यू कैन क्लियरली सी कि ये जो मेरे पास यूडीएल का लोड है ये इसको डाउनवर्ड मूव करेगा, और ये पॉइंट लोड भी इसको डाउनवर्ड मूव करेगा, लेकिन ये जो पॉइंट बी के ऊपर रिएक्शन की फोर्स है ये इसको अपवर्ड रेजिस्टिव जो फोर्स है वो यहाँ पे अट रहा है। जैसे एक एक्शन ये हो रहा है उसके अगेंस्ट ये रिएक्शन हो रहा है, तो ये जो वैल्यू है ये इसको अपवर्ड मूव करेगी, तो डिफ्लेक्शन यहाँ से अपवर्ड जाएगी, डेट इज y4। एंड यहाँ पे इसकी जो वैल्यू होगी वो हमारे पास PL1 3 over 3 EI है, जो यहाँ से बेसिकली डिफ्लेक्शन ज़ाहिर है वो यहाँ से ऊपर जाएगी, ये बीम इस पॉइंट पे तो फिक्स है ना यूजिंग दिस पिन पॉइंट, और यहाँ से भी फिक्स है, तो यहाँ से ही बीम ऊपर की तरफ मूव करेगा ना, तो ये हम इसलिए यहाँ पे L1 कंसीडर कर रहे हैं। एंड नाउ मोस्ट इम्पोर्टेंटली वी आर taking an assumption as all the linear elastic, keep in mind this thing। सो वाई बी जो है वो हम कैसे निकाल सकते हैं, सो वाई बी वुड बी इक्वल टू 0 ओवर हेयर। हाउ, क्योंकि यहाँ पे जो फोर्स लग रही है वाई बी की, यहाँ पे डिफ्लेक्शन जो है वो 0 हो रही, यहाँ पे तो डिफ्लेक्शन नहीं हो रही, क्योंकि डिफ्लेक्शन तो इस पॉइंट एंड वन के पॉइंट पे हो रही, जो कि यहाँ से हमें इंडिकेट हो रहा है, तो वाई बी 0 है, और इस इक्वल टू -y1 क्योंकि डाउनवर्ड है, -y2 -y3 प्लस y4। Now simply substitute all these terms and substitute this angle theta here, and the final result would be for by is 94.2 kilonewton। तो ये by की जो रिएक्शन की फोर्स की वैल्यू है वो हमने यहाँ पे कैलकुलेट कर ली। So from equation 1 and 2 that we derive in above, simply I'm rewrite it here, and now substitute the value of by here and here, then you come up with this value, that is AY 126 kilonewton, and moment at A and would be 65.2 kilonewton meter। So this conclude our solution of part A। ओके, अब हम पार्ट बी की तरफ चलते हैं, और पार्ट बी के अंदर हम सेम प्रॉब्लम को यूजिंग द सिंगुलैरिटी फंक्शन जो है वो सॉल्व करेंगे, और वी आर मेकिंग द assumption अगेन द linear elastic, and these are the generalized form of the singularity function। So simply write the moment equation using the singularity function। So as we know that moment is equal to EI d square y over dx, and the moment acting at point A would be MRA, and the distance at this point is definitely 0, x minus 0 power 0 over 0 factorial plus A y, that is the point load, use this form and write it here, then 73, that is the distributed load, use this generalized form and now write it here according to this situation, and then the point load again, that is 45, and it is moving downward, that's why I'm put it here negative sign here, also negative sign here, as this is moving downward. As this reaction is moving upward, so we take it as positive, and the moment for anti-clockwise we taken it as negative, and this reaction force is also moving upward, so it also take it as positive, and the singularity function form is here। Now you see कि हमने जब यहाँ पे कट किया था सेशन को, तो ये जो बी वाई टर्म है इसके राइट साइड पे आ रही है, सो वी आर going to ignore that term. So ये टर्म हमारी ज़ीरो हो जाएगी यहाँ पे। इसकी डिटेल फर्दर मैंने प्रीवियस वीडियो लेक्चर्स के अंदर भी बताई हुई है। अगर आपने वो वीडियोस नहीं देखी तो पहले आप सिंगुलैरिटी फंक्शन की वीडियो देख लें। तो ये टर्म हमारी यहाँ से सिंपली ज़ीरो हो जाएगी क्योंकि हम सेक्शन जो है वो यहाँ पे टच कर रहे हैं, तो ये टर्म उसके राइट साइड पे अट कर रही है, तो ये हमारी ज़ीरो हो जाएगी। हमने सिर्फ लेफ्ट साइड को देखना होता है जैसे मैंने पहले बताया था। तो हम इसकी इंटीग्रेशन करेंगे जी। इंटीग्रेशन करके हमारे पास ये इक्वेशन आ जाएगी और यहाँ पे अब हम बाउंड्री कंडीशन पुट करेंगे और वी नो दैट डी वाई ओवर डी एक्स एट एक्स इज इक्वल टू ज़ीरो इज ज़ीरो। यहाँ पे क्लियरली शो भी हो रहा है कि डिफ्लेक्शन यहाँ पे ज़ीरो है, तो C1 की वैल्यू जो यहाँ पे ज़ीरो आ जाएगी। इस तरह से जब आप यहाँ पे H की वैल्यू ज़ीरो पुट करेंगे और यहाँ पे ये डिफ्लेक्शन ज़ीरो होगी, तो ये सब टर्म्स आपकी कैंसिल आउट हो जाएंगी, तो C1 की वैल्यू ज़ीरो आ जाएगी। Okay, now let's again integrate this term for finding the deflection, and the equation would be shown here. For putting again x is equal to 0 in this term, and the value of C2 constant is again 0. As clearly shown here, the deflection at this end is 0. So we have this final term of singularity function, and we have to find it as a length of 2.4, and we also know that the deflection at point B will be also 0, as this is the fixed spot shown here, that is the pin type of spot. So this term also goes to 0. Substitute x here, here and there, and then solve this equation, and the final form of this equation would be ay minus 1.25 times mra is equal to 44.5, and we call it as equation number 3. So we already derive in above equation 1 and 2, and the equation 3 is shown here. So we have 3 unknown and 3 equation. So solving these 3 equations simultaneously will give us the answers for AY, BY and MR moment at point A, and these answers are the same as we derive using the superposition method. So it's all about statistically indeterminate beam. Thank you.